Bismillahirrahmanirrahim. Quote of the day: the life of this world is merely an enjoyment of delusion. This is a quote from Al-Quran. My name is Dr. Amna Khalid, and I will be presenting on the topic of hypothesis testing for proportions under the kind supervision of my professor, Dr. Saira Afsar. Learning objectives for today's presentation are introduction to proportion, steps of hypothesis testing for proportions, z-test for proportions. We will see the examples of z-test, and we will briefly discuss chi-square test. So first of all, we will see that what is the proportion. Proportion is a ratio which indicates the relation in magnitude of a part of the whole. And in a proportion, a numerator is always included in the denominator, and it is usually expressed as a percentage. These are the steps of a hypothesis testing. Why we will test the proportion using different tests. The first step is we have to state the hypothesis. Secondly, we have to decide the significance level, that is alpha. On number three, we have to compute the test statistic. Then we will define our critical value or the critical region, and according to that, we will state the conclusion. So we will, first of all, we will discuss each step one by one. As the first step was to state a hypothesis, so we will see what is a hypothesis. It's a statement, any statement which can be tested, and it is a proposed explanation of a specific phenomena. We have two types of hypothesis: null hypothesis and alternative hypothesis. We will see the example of it. For example, if we want to see the effect of a biofertilizer X on plant growth, the null hypothesis will state that by applying the biofertilizer X, there will be no difference in the plant growth. While the alternative hypothesis H1 says that after the application of biofertilizer X, there will be an increase in plant growth. So, how to identify a left-tailed test and a right-tailed test? If we, first of all, we have two-tailed test in which the alternative hypothesis contains the sign of not equal to. It means it simply says that there exists some difference, but doesn't define it, either the difference is in the form of an increase or decrease. While in a left tail test, the alternative hypothesis contains the sign of less than a less than sign. It means the effect. For example, if we are studying the effect of vaccine B and vaccine A, and we say that vaccine B is less effective than vaccine A. So this less than sign comes in left tail test. And in a right tail test, the alternative hypothesis contains the sign of a greater than or more than or larger than. For example, we say that vaccine B is better than or more effective than vaccine A. So this will be a right tail test. Then we have to see the level of significance. The level of significance is the maximum probability of committing a type 1 error. As we have already seen the types of errors, type 1 error is rejecting the null hypothesis when it is in fact true. And this probability, like this level of significance, is symbolized by the Greek letter alpha. So the type 1 error is alpha. On number three, we have to define the critical and non-critical regions. The critical or rejection region is the range of test values that indicates that there is a significant difference and that the null hypothesis should be rejected. While a non-critical or non-rejection region is the range of test values that indicates that the difference was probably due to chance and that the null hypothesis should not be rejected. So what will be the critical value? The critical value separates the critical region from the non-critical region, and the symbol used for it is a CV, critical value. This is the graphical presentation of a critical and non-critical region. So in the center of the curve, if the value falls here in the white area, then we will fail to reject the null hypothesis, or you can say that we will accept the null hypothesis. While on the tails, both on the right and the left side, if our statistic value or test value falls in this area in the red zone, then we will reject the null hypothesis. And here we have the critical value both on the plus side and the minus side, which will separate the critical from the non-critical region. So according to the types of the hypothesis, we can see that where does this critical region fall. So in this first curve, we can see that on the left tail test we have the critical region over here, and in the right tail test we have the critical region over here. And in the two-tailed test, we have critical region on both sides, on positive as well as the negative side. So, how to determine the critical value? A value of the statistic, which defines the upper and lower bounds of a confidence interval, or which defines the threshold of statistical significance in a statistical test. We will get it from the Z table, so the table calculator, and it depends on if the hypothesis is one-tailed or two-tailed, as we have already seen in this slide, that for each type the hypothesis we have different regions. So the use of a statistical test and a test value. A statistical test uses the data obtained from a sample to make a decision about whether the null hypothesis should be rejected or not. And the numerical value obtained from a statistical test is called the test value or the test statistic. Now, how we have to determine that value, that test value or test statistic? We have to use the formula for the z-test for proportions. In case of a single proportion, this is the formula. Z is equal to p hat minus p divided by square root of pq by n. Here we can see that p hat is equal to x by n. That is the sample proportion. And p is the population proportion and n is the sample size. And on the next slide, we have the z-test formula for comparing two proportions. Here we can see that Q is equal to 1 minus P, and other values are almost similar to the previous formula, like P is equal to X by N. So in this case, as we have two proportions, so X1 plus X2 divided by N1 by plus N2. This is the formula. Then we have to determine the Z value. As in case of 95% confidence interval, or usually we take the significance level alpha, that is 5% or 0.05. So in that case, we get the value of 1.96, 1.9, and the next decimal is taken from this row, that is 0.6. So 1.96. So the point where these two lines coincide is the value we have to take for the as a z value. So in this case, it will be 0.4750. Then according to this value, the value we got from this table, 0.4750. So according to this value, we have to state the conclusion. If this value falls in the critical region, we have to reject the null hypothesis. And if this value does not fall in critical region, we have to accept the null hypothesis. So now we will see the hypothesis testing for proportions. First of all, we will see the example of a single population proportion. So the proportion of malnourished children in a rural community is 70%. A researcher believes that this value is not true. He conducts survey on 200 children and found that out of those 200, 130 were malnourished. So at 95% confidence interval, is there enough evidence to reject the null hypothesis? So now we have to complete all the 5 steps on this example. So the first step was to state the hypothesis, both the null and the alternative hypothesis. So the null hypothesis will be P is equal to 0.70. It means it will be the same as done before and there will be no difference. But the alternative hypothesis is that P is not equal to 0.70. And in the second step, we will define the alpha level, that is 0.05, and the alpha value 0.05, half of it will be on the right side, the left side, and half of it will be on the right side. 0.025 over here on the plus side and 0.025 over here on the negative side. So in the next step, we have to see the z value, as we saw in the example that they said at 95% confidence interval, we have to do all the steps. So at 95% confidence interval, you can see that the z value is 1.96. So on the next step, step number 4, we have to calculate the test statistic. The formula was already given in the previous slide. So we use that formula. We put all the values over here and we found that the z value is minus 1.54. This is the value that we will see over here, that this where does this value fall, either in the non-rejection region or in the critical region. So we can see that the 1.54 value does not fall in the critical region. It's something over here before 1.96. 1.96 was the critical value. 1.96 is the defining value, critical value that separates the critical and non-critical region. So 1.54 falls in the white zone or the non-rejection or the acceptance zone. So we fail to reject the null hypothesis. Now we will see the example of hypothesis testing with two proportions. The vaccination rates in nursing homes. In the nursing home, as we mentioned in the that the researchers found that 12 out of 34 small nursing homes had a resident vaccination rate of less than 80%, while 17 out of 24 large nursing homes had a vaccination rate of less than 80%. So at the alpha or the significance level 0.05, we have to test the claim that there is no difference in the proportions of the small and large nursing homes with a resident vaccination rate of less than 80%. So we will again apply all the 5 steps. First of all, the first step is state the hypothesis. And the null hypothesis is that there is no difference. P1 is equal to P2. And the alternative hypothesis says that P1 is not equal to P2, like there is some difference. In the second step, we will find the critical values. So in case of alpha 0.05, as we have already seen from the table, the critical values are plus 1.96 and minus 1.96. On the third step, we have to find the test value. For that test value, we will apply this formula. This formula was also given in the previous slide. So by putting all the values in the formula, we finally got a test value of minus 2.70. Now we will see where does this value fall in the graph, in the curve. So in the step 4, we have to make the decision. As you can see that this 2.70 value falls in the a critical region. It's on the negative side, so it is less than minus 1.96. It falls over here, and this is the rejection region. So we will reject the null hypothesis. So what on the step 5, we have to conclude the result, we have to summarize the result. So there is enough evidence to reject the claim that there is no difference in the proportions of small and large nursing homes uh, with a resident vaccination rate of less than 80%. So we will be rejecting the null hypothesis. This was the example of using z-test for two proportions. So we have another test chi-square which can be used on the proportions, and in this slide there is a brief difference between the two tests. Z-test is used when the two populations on the two populations are when the large sample size is there, like n is more than 30, while chi-square test can be used for two samples for any sample size. Z-test, for the Z-test, the information given is standard deviation of the population and the population mean and proportion. In case of chi-square, the number of observations for each categorical variables are given. A z-test is used when the distribution is normal, and the chi-square test is used on any kind of distribution, either normal distribution or the other one. So z-test states that do these two populations differ from each other? And chi-square test determine that are these two categorical variables independent or not. So this is a brief difference between the two. Now we will to the chi-square test. The chi-square test is a statistical method used to determine whether there is a significant association between two categorical variables, and it's used in the hypothesis testing. These are the steps of hypothesis testing by chi-square. First of all, as in previous case, we have to state the hypothesis, both the null and alternative hypothesis. Second step is also same. We have to find the significance level, and mostly we are choosing it 5% or even 1% like this. Then we have to compute the expected frequencies. Here the formula is different. We have to calculate the expected frequency, that is equal to row total into column total divided by grand total. We use the 2 by 2 table and then we use this formula. Then we have the chi-square test statistic formula in which we have observed values minus expected values. We take the square of them and we divide them by the expected frequency. Then we have to determine the degree of freedom, R minus 1 and a row minus 1, column minus 1. On number 6, we have to find the critical value or the p-value. So from a chi-square distribution table, we will get these values. Then we will make the decision that if chi-square the calculated value of chi-square is more than critical value, we will reject the null hypothesis, and if it is less than alpha, then we will, or if the p-value is less than alpha, we will reject the null hypothesis. Then at the end, we have to state the conclusion or the result that whether there is a significant association or not. This was actually only a summary of chi-square. There, as we have an upcoming class on the chi-square, and a detail will be given over there. So I have not included any example over here. This is just a brief overview, so that when we move to the next class of the chi-square, we are more prepared for it. So this was all about the hypothesis testing for proportions. Now it's the time for MCQs. So question number 1 is, the probability that you will make the mistake of rejecting the null hypothesis when in fact it is true. Option A, beta error. Option B, alpha error. Option C, power of study. And option D, 1 minus alpha error.
B.
Beta option
Alpha
B.
error.
Yes, option B, alpha error.
And B.
Question number 2. Number of distinctions in a class are 2%. A researcher claims that the distinctions are more than 2%. Which of the following is the most appropriate option? Option A, it's a two-tailed hypothesis. Option B, it's a right-tailed hypothesis. Option C is the left-tailed hypothesis, and option D is the bidirectional hypothesis.
B.
Right. Yes, option B is the right-tailed hypothesis. Question number 3, a researcher wants to compare number of stage 1 breast cancer out of total breast cancer in hospital 1 with a number of stage 1 breast cancer out of total breast cancer patients in hospital 2. So the most appropriate test will be option A, z-test for means, option B, z-test for proportions, option C, paired t-test, option D, unpaired t-test.
B.
This option B, z-test of proportions. Question number 4, a researcher compared percentage obesity of school children with WHO reference percentage of obesity in school children. Which of the following tests will be most appropriately used? Option A, z-test of means. Option B, z-test for single proportion. Option C, z-test for comparing two sample proportions. And option D, unpaired t-test.
Beta B.
Yes, option B.
A.
Option B, yes, there is only a single proportion over here, population over here. Question number 5. A researcher wants to compare two proportions. He selects significance level alpha of 0.01. So what does this 0.01 alpha means? Option A, there is 1% probability that you will make the mistake of rejecting the null hypothesis when in fact it is true. Option B, there is 10% probability that you will make the mistake of rejecting the null hypothesis when in fact it is true. Option C, there is 1% probability that you will make the mistake of rejecting the alternate hypothesis when in fact it is true. And option D, there is 10% probability that you will make the mistake of rejecting the alternate hypothesis when in fact it is true.
Alpha.
Yes, option A is the correct answer. Question number 6. A researcher did study on proportion of smokers in an office. The z-test of proportion came out to be minus 1.29 at 95% confidence level. The critical value is plus minus 1.96. What should be done? Option A, accept the null hypothesis. Option B, reject the null hypothesis. Option C, accept alternate hypothesis. And option D, not enough evidence to comment.
Alpha.
Yes, option A is the right answer, as the value minus 1.29 does not fall in the critical region. Question number 10, calculate chi-square value if observed value is 4 and expected value is 6. I can give you a hint that observed minus expected square divided by expected frequency was the formula. You can see the solution of it. 4 minus 6. We take the square of it, we divide it by 6. 6 is the expected value. So the answer comes out to be 0.66. Question number 8. Which step involves comparing the calculated statistic to a threshold to make a decision about the null hypothesis? Option A, state the hypothesis. Option B, decide significance level alpha. Option C, compute test statistic. Option D, critical value or the region. And option E, state conclusion.
Delta. Critical value.
Yes, delta is the right answer. Question number 9. Which of the following best defines a proportion? Option A, difference between two variables. Option B, a relationship of part to part. Option C, a ratio that shows the magnitude of a part relative to the whole. Option D, a formula used in hypothesis testing. And option E, a statistical distribution curve.
Beta.
Option C, a proportion is a part of the whole. Question number 10. What does the critical or rejection region indicate in hypothesis testing? Option A, the region where the null hypothesis is always accepted. Option B, the region that shows the difference is due to random chance. Option C, the region of values that lead to rejecting the null hypothesis. Option D, the region used to calculate standard deviation. Option E, the region where alternative hypothesis is always false.
Charlie, C.
Yes, Charlie is the right answer. If the value falls in the critical region, we will reject the null hypothesis. So this is the MCQ's key, and this is the YouTube link where this uh, video will be uploaded. Thank you so much.
Thank you.